The night sky has always been a place of wonder, a vast ocean above our heads that is at once familiar and impossibly distant. For thousands of years, humanity has navigated by the stars, woven myths into constellations, and trembled at the sudden appearance of comets. To ancient eyes, these icy wanderers were harbingers of plague, famine, or war. Even in the modern age, when science has stripped away the veil of superstition, comets retain their aura of mystery. They are relics of creation, frozen archives of the early solar system. Yet today, one object has appeared that challenges not only our understanding of comets, but perhaps our place in the universe itself. That object is 3 Atlas, the third known interstellar visitor to enter our solar system. Unlike the countless comets cataloged before it, this one does not come from the Oort cloud, nor from any stable orbit around our sun. It drifts in from the deep void between the stars, carrying secrets we may not yet be ready to confront. And at this very moment, as it sweeps closer to the orbit of Mars, astronomers are faced with phenomena that defy explanation. Astronomer Dr. Subernardone Gun. Karen Mitchell summarized the unease with rare candor. Every comet expert agrees. 3I Atlas is unlike anything we have ever seen. Her words are not the exaggerations of a sensationalist. They are grounded in data observations that appear to mock the textbooks and graphs that generations of astronomers have relied upon. The first anomaly is its brightness. Comets usually follow predictable light curves. Their glow rises gradually as they approach the sun, as sunlight vaporizes their frozen ices. But 3 Atlas brightened at a rate far beyond any model. What began as a faint smudge visible only to sensitive instruments became, within weeks, a spectacle visible even to amateur telescopes. Its tail is no less troubling. Normally, the tails of comets align themselves with the flow of the solar wind, streaming directly away from the sun. Yet 3I Atlas seems to ignore this law, projecting a luminous filament at an angle that does not match the expected direction. Some astronomers describe it as though the comet is propelling itself, like a ship with an invisible engine. Others whisper words they dare not commit to print: designed, artificial, deliberate. As one researcher put it, the tail is defying physics. The brightness is exceeding forecasts. It almost looks engineered. But perhaps the most unsettling mystery lies not in what we see, but in what we do not. Since August, many of the world's premier observatories have fallen strangely silent. The James Webb Space Telescope, once hailed as our most powerful eye in the cosmos, has released no official images. Hubble has offered nothing. Several ground-based facilities have likewise remained quiet. The official reasoning is plausible enough during solar conjunction. The comet is obscured by the sun, hidden in a region of the sky impossible to study. But critics ask, is that really all there is to it? Could this gap in coverage be more than coincidence? Could vital data be withheld, concealed from the public eye under the justification of caution or secrecy? History gives us reason to doubt the innocence of silence. Each great leap in knowledge has been accompanied by fear, denial, or outright suppression. When Galileo first announced that Jupiter had moons, his findings were condemned as heresy, threatening the cosmic order decreed by the Church. New knowledge has always unsettled authority, because new knowledge shifts the foundation of power. And so today, with 3I Atlas blazing across the heavens, we find ourselves once again at the edge of a truth that may be too disruptive to embrace. If 3 Atlas were just another comet, it should be predictable. Its brightness curve should follow the models. Its tail should obey the solar wind. Its behavior should be boring in its familiarity. But it is not. Every observation piles contradiction upon contradiction. For those willing to look closely, the message is unmistakable. Something about this object does not fit the pattern. What then are we to make of it? Should we dismiss the anomalies as errors in measurement, illusions, born of imperfect instruments and human imagination? Or should we admit that perhaps we are seeing the first hints of a reality stranger than anything we dared expect? We now stand before a threshold, a door creaking open onto an unfamiliar landscape. Once open, such doors do not easily close. The mystery of 3 Atlas will linger, gnawing at the edges of certainty. And with each new fragment of evidence, the question will grow sharper. In the journey ahead, we will examine the strangeness in detail. First, the inexplicable acceleration of its brightening, faster than any known comet. Next, the violent expansion of its coma, a swelling of gas and dust that seems to outpace the physics of sublimation. Then the eerie green glow, bright at a wavelength where no ordinary comet should shine. And finally, the astonishing antitail, a luminous streamer that points toward the sun, as though the object were rejecting the rules of nature. Each of these anomalies will be investigated in turn, and when considered together, they may form a picture that leads us to a question larger than astronomy. Are we witnessing a natural phenomenon or something far more deliberate? This documentary is not a science lecture. It is a journey along the edges of the known, an invitation to walk where certainty falters and mystery begins. In tracing the path of 3I Atlas, we will confront the silence of institutions, the whispers of scientists, and the echoes of history. We will confront the possibility that we are no longer alone. For decades, astronomers have wrestled with the Fermi paradox, the haunting question: if the universe is filled with billions of stars and planets, where is everyone? The paradox implies a contradiction. The conditions for life seem abundant, yet the evidence for intelligence is absent. Perhaps the darker truth is that the universe has never been silent at all. Perhaps we have only just begun to notice the first signs. 3 Atlas is not merely an object cataloged in a database. It is a test of our imagination and of our willingness to face the uncomfortable. Already, scientists confide privately that something about it feels intentional. Already, the silence of institutions fuels suspicion that what we know is incomplete. And already, the public, gazing at the comet's shimmering light, senses that this might be more than just a frozen rock. As we begin this exploration, I ask you to stay with me. The path ahead will be unsettling. The evidence may disturb, the silence may frustrate, and the conclusions may frighten. But together, at the far end of this investigation, we may arrive at a truth that forces us to look not at the comet, but at ourselves. So take a breath, hold steady, for in following the light of 3I Atlas across the heavens, we may be approaching not just a celestial visitor, but a revelation. And by the time it emerges again from behind the sun, the question, are we alone, may finally receive an answer. When astronomers first turned their telescopes toward 3 Atlas, they expected a routine story. After all, comets are predictable in their behavior. As they approach the sun, heat penetrates their frozen cores. Ice sublimates into gas, carrying dust along with it. The coma forms, a glowing halo surrounding the nucleus. The tail emerges, always pointing away from the sun. And through all of this, a comet's brightness follows a well-known curve. Astronomers can calculate it with almost mathematical precision, predicting when a comet will become visible to the naked eye and how bright it should appear at each stage. But 3 Atlas refused to obey. In early September, it was faint, barely a whisper of light detectable by wide-field surveys. Yet within days, its magnitude jumped, growing several times brighter than any projection. Between September 7th and September 15th, it achieved a tripling of brightness, something no model could account for. Normally, a comet requires weeks or months to build such luminosity. This one seemed to ignite overnight. For observers, it was exhilarating. Amateurs reported seeing it with small backyard telescopes, far earlier than expected. Images flooded astronomy forums, showing a greenish glow that should not have been visible yet. Professional teams double-checked their calculations, convinced at first that their instruments were miscalibrated. But the error was not in the data. Independent observatories across different continents confirmed the same result: 3 Atlas was brightening too fast. To understand why this is so unsettling, consider the normal life of a comet. Most are small nuclei, a few kilometers across fragile conglomerates of ice and dust. As sunlight warms them, sublimation releases gas slowly, steadily, predictably. The increase in brightness is modest at first, then accelerates as the comet nears the sun, before leveling off. Astronomers have charted this curve across thousands of comets. It is one of the most reliable behaviors in planetary science. To see a comet leap ahead of the curve by such a dramatic margin is not only rare, it is nearly impossible. There are natural explanations, at least in theory. One possibility is a fragmentation event. If part of the comet's surface cracked open, exposing fresh ice to sunlight, the sudden release of material could cause a spike in brightness. But 3 Atlas shows no signs of such an outburst: no jets, no sudden debris cloud, no splitting nucleus. Another explanation is a favorable geometry, where the angle of observation makes the comet appear brighter than it really is. But again, astronomers ruled this out. The brightening was real, intrinsic, and global. Skeptics insisted the effect might be atmospheric interference, or even a quirk of the telescopes themselves. But this argument collapsed as more data poured in from different sites, from Chile to Hawaii, from the Canary Islands to South Africa. Everywhere the message was the same. The comet was defying expectations. By mid-September, whispers began to circulate in the professional community. Some said the nucleus must be larger than previously thought. Perhaps not 5 kilometers as initial estimates suggested, but closer to 10 or more. A larger nucleus could, in theory, release more material, driving up the brightness. Yet even this explanation fell short. The rate of change was simply too rapid. A large nucleus would still brighten along the same physical laws. The curve might scale upward, but it would not steepen so dramatically. A few astronomers allowed themselves to speculate more freely. Could the brightness be driven by unusual chemistry, volatile compounds, unlike those seen in ordinary comets? If so, what compounds could survive in interstellar space and then erupt with such vigor upon entering the solar system? Some suggested exotic ices, carbon monoxide, methane, or even compounds not yet cataloged, but spectroscopy yielded no clear answers. The lines were faint, puzzling, inconsistent. Nothing matched the intensity of the light increase. At this point, another layer of strangeness emerged. For a brief period, the light curve flattened, as though the comet had paused its outburst. Then, without warning, it surged again. Not a smooth, natural progression, but a staggered leap like steps in a ladder. To some, this pattern looked eerily artificial, as though the comet's energy output were being modulated, turned on and off in intervals. The suggestion is not as far-fetched as it sounds. In astronomy, light curves are the fingerprints of celestial objects. Stars that pulse, like Cepheids, do so with clockwork precision. Supernovae brighten and fade along predictable arcs. Deviations from these arcs are signals, clues to hidden processes at work. When 3 at last broke its expected curve, not once but repeatedly, it sent a signal that many could not ignore. Still, the official line remained conservative. We are likely seeing a combination of observational geometry and volatile release. One NASA spokesperson commented in September. But behind the scenes, frustration mounted. The numbers did not add up. Private correspondence between astronomers, later leaked, revealed language far less cautious. The brightening is anomalous, one note read. We have no natural explanation. And then came the public silence. After September, updates grew sparse. Major agencies ceased releasing detailed brightness data, citing routine recalibration. Amateur astronomers kept measuring, but their voices were fragmented, scattered across forums. The coordinated data sets, the ones that mattered, disappeared from public view. To the layperson, the difference between a predictable comet and an anomalous one may seem trivial. But in science, deviations are everything. A single star that refuses to dim on schedule can lead to theories of alien megastructures. A single comet that brightens too quickly can open doors to possibilities both thrilling and terrifying. If 3 Atlas is not behaving like a comet, then what is it? Some began to recall Oumuamua, the first interstellar object detected in 2017. It too had puzzled astronomers by accelerating in ways no natural model could explain. Its brightness fluctuated oddly, as though it were tumbling, reflecting sunlight off flat surfaces. A Harvard astronomer famously proposed that Oumuamua might be artificial, a solar sail sent by another civilization. The idea was ridiculed in some quarters, but it stuck. Now with 3I Atlas, the parallels are impossible to ignore. The fear is not merely that we are observing an alien probe. The fear is that we are seeing patterns repeat, hints accumulate, anomalies stack into a structure of evidence too strong to dismiss. One anomaly is coincidence. 2 is curiosity. 3 begins to feel like a message. For those who gaze skyward night after night, the sensation is electric. They are not simply watching a comet. They are watching a question take shape in the heavens, a question that no one yet dares to answer fully. Why is 3 Atlas brightening faster than expected? Why does it seem to burn with a light that refuses to obey the laws of comets? And perhaps most importantly, why are those who know the most saying the least? As we continue this investigation, we will explore further anomalies. The expansion of the coma at impossible speeds, the spectral signature of its eerie green glow, and the bizarre anti-tail that points in the wrong direction. But it all begins here with light. Light that grew too fast, too strong, too strange. Light that may not be the simple reflection of sunlight on ice, but something else entirely. And as history has taught us, light often heralds revelation. In the study of comets, there are few features as important as the coma. This vast glowing envelope of gas and dust forms when the frozen nucleus warms under the sun's rays. Ice sublimates, turning directly into vapor, and carries dust grains into space. The coma can grow to thousands of kilometers across, often dwarfing the nucleus itself, but its expansion follows a rhythm governed by physics. The process is gradual. It depends on the intensity of sunlight, the distance from the sun, and the composition of the comet's ices. For centuries, astronomers have been able to describe it in detail, mapping the coma's growth with equations that rarely surprise. But once again, 3 Atlas has defied expectation. When first measured, its coma appeared modest, roughly in line with early predictions. Yet within a matter of days, its size exploded. Telescopes recorded an expansion rate nearly twice what physics should allow. By mid-September, the coma had swollen so rapidly that it seemed to leap outward, stretching tens of thousands of kilometers further than expected. Some astronomers described it as bursting like a balloon, though the metaphor does not capture the raw scale involved. This was not a fragile puff of vapor, but a vast, coherent cloud expanding with uncanny speed. To grasp the anomaly, one must compare it to what normally happens. A comet's coma grows as solar radiation drives sublimation. The molecules released primarily water vapor, carbon dioxide, and carbon monoxide scatter sunlight, making the comet visible. The rate of expansion depends on the temperature gradient and the surface area exposed. The coma may double in size over weeks, but 3I Atlas doubled in days. The measured velocity of outflowing material was extraordinary, as though the comet had tapped into a reservoir of energy no one anticipated. Spectroscopy provided further puzzles. Observers detected faint signatures of the cyanogen radical, CN, which is common in comets and glows at 388 nanometers. But alongside it, there were unexplained emissions, inconsistent with the usual chemistry of volatile ices. The spectral fingerprints did not match known compounds. Some suggested exotic ices that had never been seen before in comets. Others speculated that the readings might be artifacts, quirks of the instruments. Yet repeated observations by independent teams confirmed that the data were real. One team in Chile measured the outflow velocities of the gas. The numbers were startling in some regions. Material was expanding at speeds twice the maximum predicted by sublimation models. To put it simply, the coma was not just growing fast, it was growing impossibly fast. Theories emerged quickly. Perhaps 3 Atlas had fractured internally, releasing pent-up gas trapped beneath its crust. If so, the sudden venting could explain the accelerated expansion. But no evidence of fragmentation was found. High-resolution images showed no debris clouds, no secondary nuclei. Others suggested that the comet might have a porous structure, allowing volatile gases to escape more efficiently. But again, this could not fully explain the sheer velocity of the outflow. The most daring voices suggested something more radical. What if the expansion was not driven by natural sublimation at all? What if it was being powered in some way by an energy source within the object itself? Such ideas were dismissed publicly, but privately, emails between astronomers betrayed discomfort. "We cannot explain this coma," one message read. "The velocities are too high. The physics does not hold." In the absence of clarity, official institutions downplayed the anomaly. "We are observing unusual but not unprecedented behavior," a European Space Agency spokesperson said. Yet those who know comets best recognize the gap between rhetoric and reality. Unprecedented is exactly what it was. The shape of the coma only deepened the mystery. Instead of a smooth, spherical halo, 3I Atlas displayed asymmetries, regions of higher density, knots of brightness that seemed to pulse. In time-lapse images, these knots appeared to move outward in waves, almost rhythmic. Some likened it to the beating of a heart. Others noted that the intervals seemed oddly regular, not the chaotic jets of gas typical of comets. Could this be coincidence? Could random outbursts of gas really produce such order? Or was something else shaping the expansion, guiding it in patterns we did not expect? Once again, parallels to Oumuamua arose. That interstellar object, too, displayed acceleration that could not be explained by normal outgassing. Some had argued that its motion resembled a solar sail, propelled by radiation pressure rather than sublimation. Now, with 3I Atlas, the echo of that debate returned. If the coma's expansion is being modulated, if it pulses with strange rhythms, could it be responding to something more than sunlight? At conferences, the topic was often skirted. Few wanted to be the first to speculate openly. The risk of ridicule was too high. Yet behind closed doors, astronomers admitted what they feared, that this was not natural. One anonymous report described the coma as performing. Another suggested that its expansion rate looked like stages of deployment, as though some hidden structure were unfolding. It is important, of course, to stress that extraordinary claims require extraordinary evidence. No one has proof that 3I Atlas is artificial. But the refusal of natural models to explain its behavior leaves a void. And in that void, imagination grows. Meanwhile, the public grew restless. Amateur astronomers posted images showing the coma's eerie size. To them, the comet seemed alive, expanding with intent. Some even joked online that it looked like an egg hatching in space. The jokes carried an edge of unease. Because what if it was? The silence of official institutions only added fuel. Data releases slowed, then stopped altogether. Agencies cited data quality issues, but the absence of transparency was conspicuous. Once again, it seemed as though the most important details were being withheld. Once again, suspicion grew. For the careful observer, the implications are staggering. If the coma is expanding faster than physics allows, then our models are incomplete or our assumptions are wrong. Either possibility is profound. To admit incomplete models is to acknowledge a gap in our knowledge of cometary physics, a gap that may conceal whole new categories of chemistry or energy. To admit wrong assumptions is to take a step further into the realm of the unthinkable, that what we are seeing may not be a comet at all. As the coma continued to grow, so too did the unease. Astronomers who once dismissed anomalies as errors began to reconsider. Journalists who sought simple explanations found none. And for those who watched the green halo swell around Threatitlas, one thought became harder and harder to ignore. Nature does not usually move this fast. The universe is patient. Stars burn for billions of years. Planets form over eons. Comets brighten slowly, predictably, obedient to the sun's heat. But 3I Atlas broke that rhythm. It expanded in defiance of time, of distance, of expectation. And in doing so, it forced us to ask, what kind of object refuses to play by the rules of physics? The answer may lie ahead in the other anomalies we will explore. But for now, the coma's impossible growth stands as a warning. This is not just another comet. This is something else. For centuries, comets have captivated observers, not only with their bright heads and sweeping tails, but also with the colors that shimmer through their comas. To the naked eye, many appear as pale smudges. Through telescopes, however, they reveal hues that tell us what they are made of. Green, for instance, has long been a familiar signature. It comes from diatomic carbon, a simple molecule released when sunlight breaks apart organic compounds in the comet's nucleus. At a wavelength of 518 nanometers, the gas glows green, producing the ghostly aura often photographed around comets. It is beautiful, but it is normal. And yet, with 3I Atlas, the green light has taken on an entirely different character. Amateurs noticed at first images showing an emerald glow far brighter than anyone expected, far earlier than it should have appeared. In most comets, the green is faint, visible only in long-exposure photography. In this case, it was startlingly vivid, almost electric. Some described it as neon-like, a piercing hue against the backdrop of stars. Professional observatories soon confirmed the anomaly. Spectroscopic readings showed an emission peak at 518 nanometers stronger than any comet of its size should produce. The light was not just present, it was dominant. Why would this be? In ordinary cases, diatomic carbon forms near the comet's surface, as sunlight fractures larger organic molecules. The production rate is relatively modest, depending on how much carbon material lies beneath the crust. But 3 Atlas seemed to be producing it in torrents. One calculation suggested the output was several times higher than any known comet at the same distance from the sun. Either its chemistry was wildly exotic or something else was amplifying the emission. Scientists searched for answers. Could the nucleus be unusually rich in carbon compounds? Possibly, but even then the emission was too strong. Could fluorescence effects be at play, with sunlight stimulating the gas more efficiently? Perhaps, but no model predicted such intensity. The glow was out of proportion to everything we know. It was, in the words of one researcher, unnerving. But the strangeness did not stop with color. The shape of the comet's tail added another layer of mystery. Normally, comets produce two tails: a dust tail, curved and golden, created by particles pushed back by radiation pressure, and an ion tail, straight and bluish, carried by the solar wind. Both tails always point away from the sun. It is one of the most basic rules of cometary physics. Yet 3I Atlas displayed something else entirely, a third structure, pointing in the wrong direction. Instead of streaming away from the sun, this luminous filament stretched toward it. It was as though the comet had grown a tail facing upstream, contradicting the laws of solar wind dynamics. Astronomers call this phenomenon an anti-tail, and in rare cases, it can occur when geometry plays tricks. Dust sheets, oriented at just the right angle, can appear to project toward the sun from Earth's perspective. But these cases are fleeting illusions, subtle and delicate. The antitail of 3 Atlas was neither fleeting nor subtle. It was bold, persistent, and unmistakable. Photographs from multiple observatories confirmed the anomaly. The antitail was real, and its brightness, combined with the vivid green glow of the coma, gave the comet an otherworldly appearance. Some images looked almost artificial, as though rendered by computer graphics rather than captured from the night sky. How do scientists explain such a sight? The cautious answer is geometry. The comet may have ejected a sheet of dust oriented in such a way that Earth's line of sight created the illusion of a tail pointing sunward. But skeptics argue the effect was too strong, too consistent, to be explained away so easily. Dust dynamics are chaotic, fragile. They do not usually produce structures of such apparent coherence. Whispers grew louder. Was the anti-tail not an illusion at all, but a genuine stream of material being directed? Was it possible that 3 Atlas was not simply reacting to sunlight, but shaping its emissions in deliberate ways? Some even proposed that the anti-tail might be a form of propulsion material vented to adjust trajectory. Such speculation remained confined to private discussions, but once seeded, it could not be ignored. The combined effect of the green glow and the anti-tail was unsettling. Together, they painted a picture of a comet behaving less like a passive object and more like something active, energetic, almost alive. For those who watched the comet through telescopes, the experience was strangely emotional. They reported a sense of unease, a feeling that the object was not merely drifting, but performing. The media, when it addressed the anomaly at all, downplayed it. Articles spoke of beautiful emerald displays and unusual dust geometry, framing the sight as a curiosity rather than a challenge to physics. But online forums told a different story. Amateur astronomers traded images with captions like, "What is this thing? And why is it glowing like a reactor?" Conspiracy theorists were quick to seize on the imagery, declaring the comet a disguised spacecraft. Even serious scientists, while rejecting such claims, struggled privately to reconcile the data with their expectations. Once again, official channels grew quiet. Detailed spectral data, which might have clarified the chemistry behind the glow, were not released. NASA and ESA issued brief notes, then moved on. The silence was conspicuous. The pattern was becoming familiar anomaly, confusion, speculation, then a retreat into guarded statements and withheld data. And so for those paying attention, the message seemed clear. Something about 3 Atlas was not just unusual, it was unprecedented. A comet that brightens too fast, expands too quickly, glows too vividly, and grows a tail in the wrong direction cannot be explained by chance alone. At some point, coincidence becomes pattern. For the careful observer, the green glow became symbolic. It was the comet's voice crying out across the void, announcing itself in a wavelength bright enough to defy ignorance. And the anti-tail was its gesture, pointing defiantly against the current of solar physics, as though to say, "I am not what you think I am." What does it mean? Theories abound. Perhaps the object is simply rich in exotic carbon ices, venting in ways we do not yet understand. Perhaps the anti-tail is nothing more than geometry, a cosmic trick of perspective. But the persistence, the intensity, and the timing all conspire to suggest something more. In science, the line between anomaly and revolution is thin. When Uranus's orbit deviated from Newtonian prediction, it led to the discovery of Neptune. When Mercury's orbit refused to conform, it paved the way to Einstein's relativity. Anomalies are not nuisances. They are signposts. They are the universe's way of telling us that we are missing something fundamental. And so with 3 Atlas, we must take the green glow and the anti-tail seriously. They are not decorations in the sky. They are data. They are signals. They are part of a larger picture that is only beginning to emerge. The next step in our journey will be to widen the frame. For 3 Atlas is not alone. In recent months, the skies have filled with visitors' comets, asteroids, fragments, all appearing in unusual clusters. To some, this is coincidence. To others, it is a swarm. And if it is a swarm, then the mystery of 3 Atlas is not just about a single object. It is about a pattern across the heavens, a pattern that may redefine what we believe about the cosmos. Astronomy is a science of patience. Objects drift through space on timescales measured in millennia. Comets arrive in the inner solar system once in a lifetime, if at all. Asteroids keep to their paths, cycling predictably year after year. The sky, despite its apparent restlessness, is orderly. It is this order that allows astronomers to track, to predict, and to understand. But in the past year, something unusual has unsettled that order. Not just the arrival of 3I Atlas, but the sudden appearance of others comets and asteroids crowding the sky as though drawn together by invisible threads. Observers began to notice it almost by accident. While chasing data on 3I Atlas, they encountered unexpected newcomers. Small bodies previously untracked revealed themselves in survey images. A few were ordinary, but their timing was not. They appeared in clusters, grouped in ways that made coincidence hard to believe. By mid-autumn, the count of newly flagged objects had risen noticeably. In professional catalogs, dozens of fresh designations appeared, some confirmed as long-period comets, others as interstellar candidates. The pattern was unsettling. Instead of being spread randomly across the calendar, they seemed to arrive together like a caravan entering the solar system. Astronomers began referring to it quietly as the swarm. Of course, the word swarm carries dangerous implications. In biology, swarms are purposeful locusts descend to consume, bees cluster to migrate. In space, the word suggests agency, coordination. Scientists hesitate to use such language, and yet the clustering was undeniable. Graphs of discovery dates showed spikes, not smooth distributions. Orbital diagrams revealed similarities, with several objects arriving along paths that intersected loosely with one another. It was as if they had come from the same region of space, a loose flotilla scattered but still related. Some explanations were offered. Perhaps we are simply getting better at finding them. With new survey telescopes scanning the skies every night, detection rates are naturally rising. But this excuse falters when the numbers are examined closely. Surveys have been running for years. The sudden spike in arrivals is new, and it coincides with the approach of 3I Atlas. Could these be fragments of a larger body, broken apart eons ago and now drifting through the galaxy together? That would explain their clustered arrival. A shattered interstellar object could scatter a family of pieces across space, each eventually wandering into the solar system. But the timing still raises eyebrows. Why now? Why here? A darker possibility is that the clustering is not natural at all. Some astronomers, unwilling to speak publicly, whispered about the idea of reconnaissance. If 3I Atlas is not an ordinary comet, then perhaps it is not alone. Perhaps the smaller bodies trailing it are part of the same story, a suite of objects arriving together, each with a role to play. To be clear, there is no evidence to prove such claims, but the mind cannot help but draw connections. Imagine standing on a beach and seeing one boat on the horizon. You might think little of it, but then imagine a dozen boats appearing, scattered across the waves, all approaching at once. Would you not wonder if they belong together? One astronomer described the sensation this way: it's as if the sky is staging something. First, the bright lead actor, then the supporting cast. He meant it as metaphor, but it captured the unease perfectly. 3I Atlas shines as the centerpiece, the comet that refuses to obey physics. Around it, a chorus of smaller objects enters the stage, subtle but conspicuous, adding weight to the sense that this is no isolated event. History offers precedents. In 1994, fragments of comet Shoemaker-Levy 9 fell into Jupiter, striking one after another in a cosmic bombardment. They had been shards of a single parent body, split apart by the planet's gravity. To observers on Earth, the event was a reminder that space is not empty, and that fragments often travel in groups. Yet even there, the explanation was clear: gravity tore the comet apart. With 3I Atlas, no such mechanism is visible. If it has siblings, their relation is far more mysterious. The clustering also awakens old fears. For decades, science fiction has imagined fleets of alien craft disguised as asteroids, creeping silently toward the inner planets. Fiction, of course, is not fact. Yet the resemblance unsettles multiple arrivals, loosely coordinated, their orbits overlapping just enough to raise questions. Some commentators, reaching for metaphors, invoke the term "a swarm in the skies." The phrase stuck. For ordinary people, the imagery is haunting. News outlets that dared to mention it described the heavens as crowded. Online discussions speculated wildly: are we being observed? Are these natural wanderers, or something more deliberate? In the absence of firm answers, imagination fills the void. From a scientific standpoint, the anomaly remains unresolved. Perhaps the swarm is coincidence, a statistical quirk amplified by human attention. After all, when one extraordinary comet dominates the headlines, our awareness sharpens. We notice other arrivals more keenly, interpreting patterns where none exist. Psychology is powerful. The human brain is wired to detect connections, even in randomness. And yet the clustering resists dismissal. The discovery dates are too tightly grouped, the orbits too suggestively aligned. If chance alone explains it, then chance is behaving strangely indeed. Some researchers turn to galactic dynamics. Could a passing molecular cloud or interstellar shock have nudged a group of objects toward our solar system? Could gravitational tides from distant stars have herded them together? These theories remain speculative, untested, but they are at least attempts to grapple with the scale of the puzzle. Meanwhile, silence reigns at the official level. Agencies acknowledge the discoveries, but without context. Lists are published, orbital elements posted, and nothing more. No effort is made to connect the dots. To the public, the message is implicit: nothing unusual is happening. To those who study the numbers, the silence feels calculated. And so the swarm remains an enigma. It may be coincidence, or it may be something more. What is certain is that Threatlas is no longer an isolated anomaly. It is part of a larger pattern, a tapestry of arrivals that suggests the universe is more dynamic and perhaps more intentional than we realized. For those watching, the impression is hard to shake. The sky, once the epitome of order, now feels like a stage preparing for an act we do not yet understand. A bright green comet blazing against the darkness, smaller companions slipping into view, a cluster of anomalies arriving not one by one, but all at once. If this is coincidence, it is a remarkable one. If it is not, then we may be witnessing the first movement of something unprecedented, a coordinated arrival, a signal written not in words but in trajectories across the night sky. The next step is to place this mystery in context. For 3I Atlas is not the first interstellar visitor to defy expectation. In recent years, we have met others: Oumuamua, with its strange acceleration, Borisov, with its more ordinary but still alien trajectory. Together, they sketch a lineage of outsiders, each stranger than the last. And 3I Atlas, in its defiance of physics, its green glow, its anti-tail, and now its apparent swarm, may be the most extraordinary of all. Every mystery in science is easier to face when it has precedent. If we have seen something before, even faintly, we can tell ourselves that what is happening now is not unique. It has a lineage, a context, a place in the evolving story of discovery. When it comes to interstellar visitors, that lineage is short but deeply unsettling. Before 3 Atlas, there were two others: Oumuamua in 2017 and Borisov in 2019. Each brought with it revelations, debates, and whispers of the extraordinary. Together, they paved the way for the questions we now ask about 3 Atlas. Oumuamua was the first. Detected in October 2017 by the Pan-STARRS survey in Hawaii, its name means a messenger from afar arriving first in Hawaiian. It was a poetic title for an object that immediately broke the rules. Oumuamua's trajectory was unmistakable, a hyperbolic orbit, passing through the solar system on a path that proved it came from interstellar space. This alone was historic. For centuries, astronomers had speculated about visitors from other stars. Now one had arrived, yet it was not the path that unsettled scientists. It was the object itself. Oumuamua did not behave like a comet. It had no visible coma, no obvious outgassing, no tail. Instead, it reflected sunlight in odd ways, its brightness fluctuating dramatically as it spun. Calculations suggested it was elongated, perhaps 10 times longer than it was wide, like a cigar or perhaps like a flattened pancake. No natural object of that shape had ever been seen. Then came the acceleration. As it passed near the sun, Oumuamua sped up, not just from gravity, but from some other force. Normally, comets accelerate when sublimating ices create jets of gas. But there was no evidence of such jets here. Spectroscopy revealed nothing. The acceleration was real, but its cause was invisible. One Harvard astronomer, Avi Loeb, made a bold suggestion. Perhaps Oumuamua was not natural at all. Perhaps it was a solar sail, an artificial craft propelled by the pressure of sunlight. His paper was met with ridicule by some, curiosity by others, and fascination by the public. Most scientists argued for natural explanations, suggesting that invisible outgassing might be occurring in ways we could not detect. But the idea lingered. Oumuamua was the first interstellar visitor, and it had behaved as if designed. 2 years later, in August 2019, the second interstellar object arrived. This one was discovered by an amateur astronomer, Gennady Borisov, in Crimea. Designated 2I Borisov, it was different from Oumuamua in nearly every way. Where Oumuamua was small, elongated, and enigmatic, Borisov was large, active, and familiar. It looked like a comet, a nucleus surrounded by a glowing coma, a tail streaming behind it. Its chemistry matched what astronomers had seen in countless other comets from our own solar system. In many ways, Borisov was reassuring. If Oumuamua had whispered of strangeness, Borisov shouted of normalcy. And yet even Borisov had its peculiarities. Its composition suggested unusual ratios of carbon monoxide to water, hinting at a birthplace in an extremely cold region around another star. Its trajectory, like Oumuamua's, was hyperbolic, confirming its interstellar origin. But overall, it fit within the bounds of what astronomers expected. Where Oumuamua seemed alien, Borisov seemed familiar. The contrast between the two was striking. Oumuamua was the outlier, the puzzle piece that would not fit. Borisov was the control, the natural interstellar comet. For a moment, astronomers breathed easier. The universe had shown us one anomaly, then reassured us with an ordinary example. But the reprieve was short-lived. Enter 3 Atlas. From the beginning, it combined elements of both predecessors, yet added new layers of mystery. Like Borisov, it displayed a coma and tail. But like Oumuamua, it defied predictions, brightening too quickly, expanding too fast, glowing too vividly, sprouting an anti-tail. It seemed to stand halfway between the familiar and the unknown, bridging the gap in unsettling ways. Consider the lineage first, an enigma with no coma, an unexplained acceleration, then a conventional comet from another star. Now, a hybrid with features of both but behavior stranger than either. What does such a sequence suggest? To some, it is evolution. The universe is escalating the puzzle, presenting us with visitors of increasing complexity. To others, it is a message. Oumuamua was the knock on the door, Borisov the polite introduction, 3i Atlas the deliberate conversation starter. The comparison also highlights the limitations of our science. With Oumuamua, we were caught unprepared. By the time telescopes turned toward it, it was already fading into the distance. We gathered scraps of data, tantalizing but incomplete. With Borisov, we had more time, more measurements, but less mystery. With 3 Atlas, we are better prepared, but the anomalies are greater, and the silence from institutions deeper. It is worth asking, what would it mean if Oumuamua were artificial, as Loeb suggested? What would it mean if 3 Atlas now displayed behaviors equally unexplainable? At some point, the burden of coincidence becomes too heavy. 2 anomalies may be tolerated. 3 demand attention. Even cautious scientists now admit the comparison. If Oumuamua was strange and Borisov was ordinary, one researcher wrote, then 3i Atlas is extraordinary. The word hangs in the air, difficult to define but impossible to dismiss. Extraordinary because it combines traits of both. Extraordinary because it adds new mysteries. Extraordinary because its timing, alongside the swarm of other objects, makes it feel deliberate. Public fascination grows with each revelation. The story of Oumuamua has already been told in books, documentaries, and endless online debates. Borisov reassured audiences that interstellar visitors could be normal. But now with 3i Atlas, the narrative is shifting again. Ordinary explanations falter. Extraordinary ones loom. For those who believe in patterns, the precedent is ominous. The first interstellar visitor was silent, fast, and strange. Second was familiar, a comfort. The third is hybrid, luminous, and unsettling. If a fourth comes, what will it be? The escalation is clear. Each visitor feels like a chapter in a story whose end we cannot yet see. History tells us that precedent guides discovery. The orbit of Uranus deviated from Newton's laws, leading to the prediction and discovery of Neptune. The anomalies of Mercury's orbit demanded Einstein's theory of relativity. Each time strangeness forced us forward. Oumuamua forced us to consider the artificial. Borisov forced us to accept the ordinary. And 3i Atlas forces us to confront the possibility that the boundary between the two is not clear at all. Perhaps that is the true lesson of precedent. Not that one visitor was alien and another natural, but that the distinction itself may be false. Perhaps the universe contains objects that straddle the line, part natural, part engineered, part relic of creation, part tool of intelligence. If so, then 3i Atlas may not just be extraordinary. It may be archetypal, the first of a category we have not yet defined. As the comet continues its approach, the shadows of Oumuamua and Borisov loom large. Their stories remind us that interstellar visitors are not curiosities. They are messages, each written in the language of anomaly. And now, with 3i Atlas blazing against the Martian sky, we may be reading the most complex message yet. When faced with mysteries that strain the boundaries of reason, scientists instinctively reach for conservative explanations. It is a habit rooted in caution, a guard against speculation. Before invoking the extraordinary, they ask, could the ordinary suffice? With 3i Atlas, one of the most persistent conservative interpretations is known as the debris field hypothesis. At its heart lies a familiar story of breakups, fragments, and the detritus of celestial collisions. The hypothesis begins with an image, a massive body, perhaps a comet of unusual size, or even a small planetoid, wandering through interstellar space. Over eons, stresses accumulate: thermal cracking, gravitational tugs from passing stars, impacts with other drifting objects. Eventually, the body shatters. Its fragments scatter across the void, following roughly parallel paths. Loosely bound by their shared momentum, they drift like shards of glass scattered across a frozen lake. After millions of years, they spread apart, yet still retain faint echoes of their origin. If such a family of fragments wandered into our solar system, astronomers might see not one object, but many. In this view, 3 Atlas would be only the brightest piece of a fragmented whole. We know this story well because we have seen it unfold close to home. In 1994, the world watched as fragments of comet Shoemaker-Levy 9 plummeted into Jupiter. The comet had been torn apart by Jupiter's immense gravity during a close pass, breaking into over 20 major pieces. For days, the fragments struck the gas giant one after another, each impact releasing energy on a planetary scale. The scars on Jupiter's clouds were visible from Earth-black bruises larger than our planet itself. It was a vivid reminder that cosmic bodies do not endure unchanged. They split, scatter, and leave trails of debris. There are other examples. The spectacular Leonid meteor storms of the 19th century, where thousands of meteors lit the sky each hour, were eventually traced to fragments shed by Comet Tempel-Tuttle. The torrid meteor stream, responsible for annual showers on Earth, is believed to be the residue of a giant comet that broke apart tens of thousands of years ago. The universe is filled with such detritus. To suggest that 3 Atlas might belong to a similar family is hardly radical. Proponents of the debris field hypothesis argue that the anomalies surrounding 3 Atlas may be illusions born of fragmentation. A fractured comet may brighten irregularly as new surfaces are exposed, releasing sudden bursts of gas. Its coma may expand unpredictably, driven by unstable jets from fractured crust. Even an anti-tail might arise if fragments eject dust sheets in unusual orientations. If 3i Atlas is just one shard among many, its bizarre behavior could reflect the chaotic consequences of a long-ago catastrophe. But here the hypothesis begins to strain. If the swarm of new objects arriving with 3i Atlas were all fragments of a single parent body, their orbits should align more neatly. Instead, while some similarities exist, the trajectories are messy, spread across space, as though shaped by forces beyond a single breakup. Moreover, the anomalies of 3 Atlas remain stubborn. A fragmented comet might flare unpredictably, but not brighten with the precision and speed observed. Its coma might surge, but not expand at velocities double the known limits of sublimation. Its tail might split, but not persistently defy the solar wind. The data resist tidy classification. To salvage the hypothesis, scientists appeal to unfamiliar chemistry. 3 Atlas, they argue, is not a solar system comet. It was born around another star in conditions alien to us. Perhaps it contains volatile ices we have never encountered, compounds that erupt more violently than water or carbon dioxide. Its crust, battered by cosmic radiation during its million-year journey, may have grown brittle, prone to explosive venting. In this light, its anomalies may be natural, but foreign expressions of a body shaped in another stellar nursery. The metaphor often used is driftwood. To a child who has never seen the sea, a piece of driftwood might seem carved by human hands, its curves too deliberate, its edges too smooth. Yet it is only the product of waves, currents, and storms. So too, 3i Atlas may appear crafted, even deliberate, when in fact it is only driftwood from another star system, shaped by forces we cannot yet imagine. The analogy is comforting, but it does not erase the unease. Driftwood does not glow electric green. Driftwood does not expand its halo in pulses, almost rhythmic. Driftwood does not carry with it a retinue of smaller fragments, timed so neatly with its arrival. The debris field may explain parts of the mystery, but not the whole. And so some turn the hypothesis inside out. What if the debris is not natural at all? What if the fragments are not remnants of a comet, but wreckage of something greater? Imagine a colossal construct, built by intelligence and shattered long ago. Its pieces, scattered across space, would drift like cosmic ruins. They would look like comets, irregular, tumbling, shedding material, but their behavior might betray a hidden origin. In this view, 3I Atlas is not driftwood. It is wreckage. Not a messenger, but a gravestone. The idea chills even those who entertain it. If true, the anomalies of 3 Atlas may not be signs of activity, but of decay. The green glow, the anti-tail, the rapid expansion symptoms not of control, but of collapse. Perhaps we are not witnessing a probe, but the death of one. Perhaps 3I Atlas is the fossil of intelligence, drifting into our sky as mute evidence that civilizations rise and fall, leaving behind only fragments. Skeptics push back hard. Extraordinary claims require extraordinary evidence, and wreckage is a claim without proof. There are no visible structures, no metallic spectra, no signs of symmetry. All we see is dust and gas. To leap from debris to relic is, they argue, a step too far. Yet the imagination lingers, because the anomalies refuse to go away. When nature strains belief, the mind begins to wonder whether something more is at work. What is undeniable is that the debris field hypothesis widens the stage. It shifts our perspective from a single object to a larger pattern. 3I Atlas is not alone. The swarm of arrivals in recent months suggests a shared origin, whether natural or otherwise. The sky does not usually stage such crowded performances. Something binds these arrivals, even if we do not yet know what. For the public, the image of wreckage resonates. Newspapers and blogs describe shards of alien worlds, splinters of cosmic cataclysms, debris of lost civilizations. The language is evocative, the pictures compelling. We imagine a planet torn apart, its fragments wandering the galaxy until, by chance, they found our sun. We imagine ancient ruins adrift in the void, silent but eloquent. For scientists, the hypothesis is a mirror. It reflects our desire to fit anomalies into the frameworks we already understand. It shows the tension between caution and imagination, between driftwood and relics. Above all, it reminds us that interstellar space is not empty. It is littered with history, natural or artificial, that occasionally crosses our path. And so the debate continues. Is 3I Atlas a shard of a shattered comet, a cousin to the debris fields we have long known? Or is it part of something greater, a relic of intelligence whose ruins drift silently through the cosmos? We cannot yet say. What we can say is that the debris field hypothesis forces us to look beyond a single glowing body in the sky. It demands that we see it as part of a family, a history, a story larger than itself. And in that shift of perspective lies its power. Because if 3 Atlas is indeed part of a debris field, then every fragment is a page in a story billions of years old. And if those fragments are not merely natural, then we may be reading the closing chapter of a civilization we will never meet. Among all the theories attempting to explain 3I Atlas, few inspire as much intrigue and unease as the so-called scout theory, where the debris field hypothesis sees fragments of a long-dead body and conventional models seek exotic chemistry. The scout theory dares to suggest something more deliberate. It proposes that 3I Atlas is not simply drifting into our solar system, but has come with purpose. It is not wreckage. It is reconnaissance. The logic begins with the anomalies. A comet that brightens 3 times faster than predicted. A coma that expands at double the expected velocity. A green glow so vivid it rivals natural emission rates. A tail that points the wrong way, behaving less like passive dust and more like controlled exhaust. These are not the behaviors of an ordinary comet. To some, they are signatures. To others, signals. The scout theory suggests that the brightness variations are not random outbursts of sublimating ice, but intentional modulations. The green glow at 518 nanometers, for example, could be interpreted as a beacon, a wavelength chosen not because it is natural, but because it is conspicuous against the stellar background. Likewise, the so-called anti-tail could be more than geometry. It could be thrust, small bursts of ejected material designed to alter trajectory, steering the object with subtle precision. Of course, the immediate objection is simple: extraordinary claims require extraordinary evidence. Where is the proof? Where is the structure, the symmetry, the metal that would betray engineering? The scout theory acknowledges this absence, but argues that intelligence might disguise itself. If a probe wished to enter a system unnoticed, what better camouflage than a comet? To cloak in ice and dust is to hide in plain sight, indistinguishable from millions of other bodies. The very ordinariness of comets becomes the perfect disguise. This idea is not new. In the 1960s, long before Oumuamua or Borisov, Speculative papers in astrophysics journals considered the possibility that alien probes might lurk among comets. Carl Sagan himself wrote that comets could be ideal vehicles for interstellar exploration, their icy shells providing protection against radiation and their volatile ices offering fuel. The concept lingered at the edges of science fiction and speculation for decades. Now, with 3 Atlas, it returns with new urgency. Supporters of the theory point to the timing. Why now, they ask? Do we see such a cluster of interstellar visitors? Why does 3I Atlas appear alongside a swarm of other objects, as if part of a coordinated arrival? If this is reconnaissance, then the logic is chilling a fleet of disguised scouts entering the solar system together, each probing, observing, reporting. But reconnaissance for what? That is the question that ignites imagination. Some envision harmless survey missions, robotic explorers mapping planetary systems across the galaxy. Others fear more ominous motives assessment before contact, or worse, before exploitation. The scout theory does not claim to know intent. It merely suggests that 3 Atlas is not a passive rock, but an active instrument. The evidence marshaled is circumstantial, yet compelling when arranged as a narrative. Brightness modulations interpreted as coded signals. A green glow viewed as deliberate choice. An anti-tail as propulsion. Silence from major observatories interpreted as suppression, a reluctance to admit what the data imply. Each piece alone might be dismissed, but together they form a pattern that whispers of intention. Skeptics insist that the theory overreaches. They note that comets are notoriously unpredictable. Outbursts, jets, and asymmetric tails are common, even if poorly understood. The human brain, wired to see patterns, strings anomalies into stories. What we call signal may be nothing more than noise. And yet even skeptics concede that 3 Atlas is unusual. They admit that the anomalies strain existing models. They simply refuse to cross the line into intelligence. For the public, however, the scout theory resonates. It transforms a distant comet into a character, an actor on the stage of cosmic history. Headlines speak of alien scouts and messengers from afar. Documentaries dramatize the possibilities. Forums buzz with speculation. If 3I Atlas is a scout, who sent it? How long has it been traveling? And most unnervingly, what happens when it reports back? The emotional impact cannot be overstated. For centuries, humanity has looked up at the night sky and wondered if we are alone. The scout theory suggests that the question is no longer abstract. If true, the answer may be drifting above us now. Glowing green, its anti-tail pointed defiantly against the sun. The loneliness of the cosmos is replaced by the intimacy of surveillance. We are not isolated. We are observed. Some thinkers extend the theory further, suggesting that Oumuamua in 2017 may have been the first scout, a fast flyby to test our response. Borisov in 2019, the second, a control ordinary in appearance to lull suspicion. And now 3 Atlas, the third, with behaviors that cannot be ignored. If so, the escalation is deliberate, a sequence designed to move us step by step toward recognition. First curiosity, then reassurance, then revelation. Is this paranoia or pattern? History shows that anomalies often precede revolutions in science. Uranus's orbit led to Neptune. Mercury's anomalies led to relativity. Might 3I Atlas's anomalies lead to the recognition of intelligence beyond Earth? The thought is staggering, but not impossible. The scout theory, then, is not only about the comet. It is about us, about how we interpret evidence, how we balance skepticism with imagination. To dismiss the theory outright is to risk missing the extraordinary. To embrace it uncritically is to risk delusion. The truth, as always, lies in the tension between. What cannot be dismissed is the sense of unease that 3 Atlas inspires. Natural or not, it behaves in ways that feel intentional. Its glow, its tail, its timing, they provoke not just curiosity, but a primal instinct, the awareness of being watched. And perhaps that is the true power of the scout theory. Not that it proves intelligence, but that it forces us to confront the possibility. It makes the night sky feel less empty and far more alive. As 3I Atlas continues its journey toward the sun, the question lingers if it is a scout. What comes next, a message, a fleet, or only silence as it slips back into the dark? We do not yet know, but for now we watch. And in watching, we find ourselves reflected in our fears, our hopes, our longing for connection. Whether 3I Atlas is driftwood or debris, relic or reconnaissance, the scout theory ensures that we cannot look at it as just another comet. It has become in our minds a mirror. And in that mirror, we see not only the possibility of others, but the truth of ourselves. In the summer of 1950, at Los Alamos National Laboratory, physicist Enrico Fermi posed a question so simple it continues to haunt us today. Where is everybody? Surrounded by colleagues discussing the possibilities of interstellar travel and extraterrestrial civilizations, he calculated that, given the age of the galaxy and the number of stars, intelligent life should have had more than enough time to appear and spread. Yet the sky was silent. This silence became enshrined as the Fermi paradox, the contradiction between the high probability of alien life and the absence of evidence. For 75 years, scientists, philosophers, and dreamers have wrestled with Fermi's question. Some argue that intelligent life is rare, a cosmic accident unlikely to repeat. Others suggest that civilizations self-destruct before they can reach the stars, undone by their own technologies or conflicts. Still others propose that we are being deliberately ignored, quarantined in what some call the cosmic zoo. Explanations abound, but the paradox remains. Now, in the shadow of 3 Atlas, Fermi's question takes on new weight. If this comet, with its anomalies and mysteries, is more than it appears, then perhaps the paradox is not a contradiction at all. Perhaps it is an illusion born of our limited perspective. For the scout theory hinted at something active, deliberate. The debris field hypothesis hinted at histories we cannot see, and the swarm suggested coordination. Together, they form a troubling possibility that the silence Fermi noticed was never silence at all. We may simply have been unable or unwilling to recognize the signals when they appeared. Consider the timeline. In 2017, Oumuamua passed through, silent but strange, accelerating without explanation. In 2019, Borisov arrived, a more conventional comet, reassuring in its normalcy. Now in 2025, 3 Atlas blazes across the sky with anomalies that defy physics. What if this is the answer to Fermi's question? Not where is everybody, but they are here, and we are only just beginning to notice. To imagine this possibility is to turn the paradox inside out. The absence of evidence may not be evidence of absence. It may be evidence of disguise. For if intelligent life wished to observe quietly, it would not announce itself with radio beacons or megastructures. It would slip among the ordinary, cloaked as natural phenomena, comets, asteroids, interstellar debris. What better way to be everywhere yet nowhere than to be mistaken for background? The implications are profound. If 3 Atlas is indeed more than a comet, then Fermi's paradox was not a paradox at all, but a misperception. The galaxy may be full of intelligence, hidden in plain sight. We were simply too naive, too bound by expectation, to recognize it. Fermi asked, where is everybody? The universe may now be answering, we were always here. You just didn't know how to look. Of course, such speculation demands caution. The risk of anthropomorphism projecting intention where there is none is high. Comets are chaotic, unpredictable bodies. Anomalies are common. To leap from anomaly to intelligence is a dangerous step. Yet the persistence of the anomalies, their clustering, their uncanny timing, gnaws at the edges of skepticism. At some point, coincidence becomes pattern, and pattern demands explanation. This is where the paradox cuts deepest. For decades, scientists sought radio signals, scanning the heavens for deliberate broadcasts. SETI projects listened for decades, hearing nothing but noise. The absence reinforced the paradox. If civilizations exist, why do they not speak? But perhaps the question was wrong. Perhaps civilizations do not broadcast at all. Perhaps they observe silently, sending scouts that mimic comets, probes that hide among asteroids. If so, we would never hear their voices. We would only see their shadows, anomalies like Oumuamua, Borisov, and now 3 Atlas. And what of motives? Why, if intelligence hides among us, does it not reveal itself? The answers echo through Fermi's paradox as well. Perhaps they wait until we are ready. Perhaps they have rules of non-interference, a cosmic version of quarantine. Or perhaps, more chillingly, they reveal themselves only when necessary, when observation must become action. If 3 Atlas is a scout, then the question is not whether others exist, but what they intend. For humanity, the psychological shock of this possibility is immense. Fermi's paradox has long offered comfort. The silence implied solitude, and solitude implied safety. We could imagine ourselves as the first, the only, the pioneers. Now, the idea that the silence was never silence but surveillance strips away that comfort. It replaces isolation with intimacy, the intimacy of being watched. The paradox becomes not where is everybody, but how long have they been here? The broader implications stretch beyond astronomy. If intelligence has been present all along, hidden in comets and debris, then our understanding of history shifts. Every unexplained anomaly in the night sky becomes suspect. Every irregular comet, every meteor swarm, every unexplained brightening becomes a potential data point in a much larger pattern. We must reread the sky not as empty, but as crowded with possibility. And in this rereading, humanity finds itself at a crossroads. Do we dismiss anomalies as noise, clinging to the comfort of solitude? Or do we confront the possibility that Fermi's paradox has already been answered, not in silence but in disguise? Either choice demands courage. One requires the courage to ignore unsettling data. The other requires the courage to face the possibility that we are not alone and never have been. Some scientists whisper of a deeper irony. Perhaps Fermi's question was itself the answer. To ask where is everybody is to assume absence. To assume absence is to blind oneself to presence. In this view, the paradox is not a cosmic riddle, but a mirror of human arrogance. We expected aliens to speak our language, send our kind of signals, follow our expectations. When they did not, we concluded they were not there. But perhaps they were here all along, just not in the forms we imagined. 3 Atlas forces us to reconsider. Its anomalies press us to admit that the universe may be speaking in dialects we have not yet learned. Its presence alongside other interstellar objects suggests coordination, not chaos. Its defiance of physics hints at design, or at least at knowledge beyond ours. And in all of this, the shadow of Fermi's paradox looms large. As the comet continues its arc past Mars, glowing green and trailing its anti-tail, the paradox shifts from abstract philosophy to urgent question. No longer, where is everybody? But what happens if we finally see them? Perhaps the answer will be benign. Perhaps 3 Atlas is nothing more than driftwood, debris masquerading as messenger, a reminder that the cosmos is stranger than we expect but still natural. Or perhaps it is a scout, and the paradox has been resolved not by absence, but by presence. If so, then the silence of the stars was never silence at all. It was strategy. And if it is strategy, then the most haunting question remains not where they are, but what they want. In astronomy, images are everything. They are the currency of trust, the proof of discovery, the language through which mysteries are revealed. A press release without images is barely a press release at all. It is speculation. From the first daguerreotypes of the moon to the breathtaking color mosaics from the Hubble Space Telescope, visual evidence has always been the bridge between the scientific elite and the public. When a comet flares or a supernova erupts, it is the images that make the event real. That is why the silence surrounding 3 Atlas has been so unnerving. For an object that has provoked such extraordinary attention, the absence of official images is glaring. Early in its approach, amateur astronomers captured hundreds of exposures, posting them online with astonishment. They showed a coma swelling faster than expected, tails splitting in strange directions, and an emerald glow bright enough to pierce suburban light pollution. These images circulated freely, unfiltered, as amateur astronomy often does. But then, as the object neared solar conjunction in August, a strange thing happened. The flow of official images slowed to a trickle. In normal circumstances, this would be the moment of peak coverage. Professional observatories would release high-resolution composites. Space agencies would post side-by-side comparisons, showing how the comet evolved. Spectrographs would be shared, annotated with colorful lines and confident captions. Instead, silence. Press releases became vague. Images, when released, were low resolution, heavily processed, or suspiciously delayed. The object that should have been the most photographed in the sky became, paradoxically, the least visible. The explanation offered was simple enough: superior conjunction. When a comet passes behind the sun from Earth's perspective, it enters a period of invisibility. Solar glare overwhelms sensitive instruments, making observation difficult or impossible. Professional astronomers explained that the lack of images was a natural consequence of geometry. Patience, they said. When it emerges from behind the sun, the cameras will resume. But for some, this was too neat. Superior conjunction is real, but it is not absolute. Instruments like the Solar and Heliospheric Observatory SOHO and the Solar Dynamics Observatory SDO have long-tracked comets grazing the sun. These satellites often capture stunning images of objects plunging into solar fire. Why then did these same satellites produce so little of 3 Atlas? Why did the usual torrent of raw data seem to dry up just when anomalies were at their peak? Conspiracy thrives in such voids. Online forums buzz with speculation. "Where are the images?" became a rallying cry, repeated in threads and videos. Some suggested technical failures, but the timing seemed too precise. Others suggested deliberate withholding, that agencies had the data, but were keeping it out of public view. Theories multiplied. Perhaps the green glow was too strong, revealing something artificial. Perhaps the anti-tail appeared too coherent, betraying deliberate propulsion. Perhaps, as one amateur put it bluntly, they don't want us to see what it really is. Skeptics countered that this was paranoia. Space agencies are bureaucratic, not conspiratorial. Delays happen, processing takes time, and public communication is often clumsy. To see malice in absence is to mistake incompetence for conspiracy. Yet even skeptics admitted that the silence was unusual. NASA, ESA, and JAXA all pride themselves on outreach. Why then were their releases so muted? Why the sudden reluctance to showcase one of the most remarkable interstellar visitors in history? Some scientists, speaking off the record, acknowledge frustration. "We're seeing things we can't explain," one astronomer said in a leaked recording. And when you can't explain, the safest thing is to say nothing. In that admission lies a deeper possibility, not conspiracy, but caution. Perhaps the images exist, but reveal anomalies too stark to present without interpretation. To show them would be to invite questions the agencies are not ready to answer. Silence becomes a strategy, a way to delay the inevitable reckoning. The situation recalls earlier controversies. When Oumuamua passed in 2017, no high-resolution images existed, only light curves and artists' impressions. The absence fed speculation that something was being hidden. When Mars once showed seasonal methane spikes, agencies hesitated to release data until confident. When Saturn's moon Enceladus displayed geysers, it took years for NASA to release the full images, waiting for corroboration. Silence in these cases was not always suppression, but prudence. Still, the public rarely perceives prudence as benign. In a world saturated with information, absence feels like concealment. The irony is that amateurs filled the void. Backyard astronomers with modest telescopes became the primary chroniclers of threatless. Their raw images, often grainy and uneven, carried an authenticity that polished agency releases lacked. Forums became archives, each post a fragment of the visual record. In the absence of official confirmation, these amateurs became the historians of anomaly. And with each image posted, the contrast with silence grew sharper. The psychological effect has been profound. In cultures shaped by visual media, to lack images is to lack reality. Silence becomes absence, and absence becomes threat. The phrase, "Where are the images?" is more than a question. It is an accusation. What are you hiding from us? Some commentators invoke pop culture parallels. In the film Don't Look Up, governments downplay a comet heading for Earth, suppressing images to avoid panic. The resemblance is uncanny. Reality may not mirror fiction, but fiction shapes perception. The very act of withholding feeds suspicion, regardless of motive. Meanwhile, those who study the raw numbers know the truth is stranger still. The data that have been released, spectral peaks, orbital elements, coma measurements, already defy explanation. To see the images might only deepen the unease. Perhaps the agencies are not hiding alien technology, but simply buying time. For in the face of anomalies, silence can be more comforting than uncertainty. But silence cannot last forever. The comet will emerge from behind the sun. Amateur telescopes will turn toward it again. Images will flood the forums. And when they do, the question will return with sharper edge: were the agencies withholding, or were they simply unprepared? The answer may not matter. In the court of public opinion, perception is truth, and the perception of silence is already shaping the narrative. Ultimately, the absence of images tells us less about Three Atlas than about ourselves. It reveals our hunger for transparency, our mistrust of institutions, our tendency to see conspiracy and uncertainty. It shows that, in the modern world, information withheld is as powerful as information revealed. And it reminds us that when the sky presents mysteries, we demand to see them with our own eyes. "Where are the images?" is thus more than a cry for data. It is a cry for trust. Until the silence breaks, until the comet shows itself again, we will continue to wonder not only what Three Atlas is, but what those who watch it already know. For centuries, astronomy has thrived on openness. Observations are logged, data shared, images published, papers archived. From Galileo sketching Jupiter's moons to the Hubble telescope streaming breathtaking imagery, the story of the cosmos has unfolded in public view. Transparency is the lifeblood of science. And yet, when it comes to Three Atlas, the institutions we trust to illuminate the heavens have fallen silent. NASA, ESO, YAXA, these acronyms once carried a weight of assurance. They were the guardians of cosmic truth, releasing images, data, and explanations to the world. They taught us to trust the sky. But since the anomalies of 3 Atlas began to mount the rapid brightening, the strange expansion, the green glow, the anti-tail, their voices have dimmed. Official statements are sparse. Press releases are vague. High-resolution images, if they exist, are locked away. The silence is deafening. At first, the excuses seem plausible. Superior conjunction, technical limitations, the backlog of data processing. Science moves slowly, after all, but weeks stretched into months. The comet that should have been a global spectacle, a teaching moment for school children, a gallery of images shared worldwide, was instead wrapped in shadows. Silence became the story. Why? What motivates such reticence? One possibility is simple caution. Institutions have been burned before. When reports of Martian canals spread in the late 19th century, fueled by flawed telescopes and overzealous imaginations, trust eroded. When NASA's Viking mission in the 1970s produced ambiguous results about life on Mars, sensational headlines turned cautious data into disappointment. Agencies learned the cost of overpromising. Silence, they discovered, is safer than speculation. Another possibility is fear of panic. Humanity is no stranger to conspiracy. A green glowing comet defying physics is fertile ground for paranoia. To release raw images without context might inflame hysteria, feeding narratives of alien probes or impending doom. In an age where misinformation spreads faster than light, institutions may believe that silence is protection. By controlling the narrative, by withholding what might be misunderstood, they think they are shielding the public from fear. But silence breeds fear just as surely as images do. When people see nothing, they imagine everything. And imagination rarely errs on the side of reassurance. Forums filled the gap. Amateurs posted grainy images. Commentators drew comparisons to Don't Look Up, a story of governments hiding truth to avoid chaos. Institutions may have intended to maintain calm, but their silence only amplified suspicion. History provides painful parallels. During the Chernobyl disaster in 1986, Soviet officials withheld information, insisting all was under control. The silence shattered trust, leaving scars that persist decades later. When institutions go quiet, people assume the worst. And in the case of 3 Atlas, the worst is easy to imagine. Some insiders whisper of another reason: the data themselves. "We're seeing things we cannot explain," one astronomer confided anonymously. "And until we can explain, we cannot speak." It is not malice, but paralysis. Agencies accustomed to authority fear admitting ignorance. To say we don't know is to risk credibility. Better to say nothing. Better to wait. But waiting in the age of instant communication is indistinguishable from hiding. The silence also reveals the fault lines of science in the modern world. Once, only a handful of observatories could watch the skies. Now, amateurs with modest telescopes can capture data once reserved for professionals. Social media ensures that images, once posted, spread worldwide in hours. In such an environment, silence no longer conceals. It exposes. Every day without official images, every press release without clarity, becomes evidence in the court of public opinion that something is being suppressed. And so trust erodes. NASA, ESA, JAXA, once revered, are now accused of collusion. Their silence is read not as prudence, but as conspiracy. "Why are they hiding this from us?" becomes the refrain. The institutions intended to guide humanity through cosmic discovery find themselves cast as gatekeepers of hidden truths. Whether justified or not, the perception is real. And perception shapes reality. The tragedy is that silence is unnecessary. The public is not fragile. When confronted with the first image of a black hole, humanity embraced it with awe, not fear. When Hubble revealed galaxies stretching to infinity, people did not panic, they marveled. Transparency builds resilience. Secrecy builds suspicion. By withholding, institutions deny humanity the chance to confront the cosmos honestly. Some argue the silence is not even coordinated, but systemic. Bureaucracies move slowly. Data must be verified, peer-reviewed, sanitized for public release. In that lag, silence appears. Yet when the object is 3 Atlas, an interstellar visitor blazing with anomalies, delay feels like deceit. What in other contexts would be routine becomes, here, intolerable. There is also the shadow of geopolitics. Space is not only science, it is strategy. Data about unusual objects may be classified not because they suggest aliens, but because they suggest vulnerabilities. If 3I Atlas were to pass near satellites, if its anomalies hinted at phenomena that could affect defense, governments might lock down information for reasons unrelated to astronomy. The silence may be less about hiding cosmic truth and more about guarding earthly power. Still, the effect is the same. The institutions appear complicit in concealment. And into that void rushes speculation, conspiracy, and distrust. The comet itself becomes less the mystery than the silence around it. People ask not only, what is 3I Atlas, but why won't they tell us what they see? In this way, the institutions have become characters in the drama. NASA is the cautious elder, ESA the guarded partner, JAXA the distant observer. Together, their silence forms a chorus, each absence harmonizing into suspicion. They stand not as explainers, but as withholders, their reputations eroding in the glare of a green comet they refuse to show. And so the question lingers, what would happen if they spoke? What if tomorrow? NASA released high-resolution images of 3I Atlas, showing anomalies beyond dispute structures in the coma, coherence in the anti-tail, patterns in the brightness. Would the world panic? Or would it, as with the black hole, simply marvel? Would humanity collapse into fear or rise into wonder? We may never know because silence prevents the test. Instead, the void grows. Each day, without images, without explanations, the institutions slip further from trust. In their caution, they have become the very conspirators they fear being accused of. The story of 3 Atlas is thus not only about the comet, it is about us, about institutions in an age of transparency, about the fragility of trust, about the cost of silence. The comet glows green in the sky, but the greater mystery may be the silence it has inspired on Earth. Perhaps the institutions believe they are protecting us. Perhaps they are protecting themselves. Perhaps they are protecting nothing at all, merely ensnared in bureaucracy. But to the public, none of that matters. Silence is silence, and silence when the sky burns with mystery is indistinguishable from betrayal. When the public asks questions, institutions often remain silent. But silence alone rarely holds. Into the vacuum steps another player, media. For centuries, newspapers, broadcasters, and now digital platforms have mediated the relationship between science and society. They frame stories, choose angles, amplify certain voices while muting others. In principle, they are watchdogs, holding power accountable. In practice, they are often partners in shaping perception. With 3I Atlas, that partnership has taken a darker turn. The comet's anomalies are undeniable. Amateurs see them through their telescopes. Forums exchange images and data daily. Yet in mainstream media, the narrative is curiously muted. Headlines describe a beautiful visitor from interstellar space, a rare cosmic spectacle, or a harmless comet lighting up the sky. Words like harmless spectacle, beautiful are repeated, smoothing over anomalies with the balm of wonder. Missing are terms like unexplained, mysterious, defying physics. The tone is reassurance, not inquiry. This is not accidental. Editors know that fear sells, but panic destabilizes. A comet behaving strangely could ignite wild speculation. In an age where misinformation spreads instantly, news outlets are cautious. They rely heavily on official sources, and when those sources go silent or evasive, so too do the headlines. NASA says little, ESA withholds images, and the media fills the gap with safe language. No cause for alarm, they repeat, echoing a script familiar from countless crises. The dynamic recalls the 2121 pandemic headlines that minimized uncertainty to avoid public panic, or the early climate reports that softened language to prevent backlash. Media, like government, fears chaos, and so it chooses calm narratives, even when reality is anything but calm. But calm has consequences. When people sense dissonance between what they see and what they are told, trust collapses. Amateur astronomers see green glows and anti-tails with their own eyes. Yet newspapers call it a typical comet display. The contradiction breeds suspicion. If they lie about the comet, what else are they lying about? Governments, too, play their part. Space is not only science, it is strategy. Satellites, surveillance, defense systems all depend on orbital awareness. An anomalous object near Mars is not just an astronomical curiosity, it is a potential threat, or at least a potential unknown. For defense agencies, the unknown is intolerable. Better to control the narrative, to keep anomalies classified than to admit ignorance. Thus, silence hardens into policy. The parallels to fiction are uncanny. In the film Don't Look Up, a comet approaches Earth, yet governments and media collude to suppress panic, reframe the narrative, and even exploit the crisis for profit. At first, the film was satire. Now, for many watching 3 Atlas, it feels like prophecy. Don't look up becomes don't ask questions. The resemblance fuels conspiracy life, imitates art, and art becomes evidence of collusion. It is easy to dismiss such fears as paranoia. But history offers cautionary tales. In 1947, when an object crashed near Roswell, the U.S. military first described it as a flying disc, then swiftly retracted the statement, calling it a weather balloon. The reversal seeded decades of distrust. In 1986, during Chernobyl, Soviet media assured citizens there was no danger, even as radiation spread across Europe. Silence and deception, meant to maintain order, only deepened fear. With 3i Atlas, the pattern echoes. Officials say little. Media repeats reassurances. Meanwhile, anomalies multiply. The public senses a gap, and into that gap pours speculation. The very attempt to control the narrative fuels its loss. Why then does deception persist? Some argue it is paternalism. Governments believe the public cannot handle uncertainty. Panic, they say, would disrupt markets, destabilize politics, erode trust. Better to curate reality, to give people comfort rather than chaos. Others argue it is self-protection. Admitting ignorance risks authority. If NASA or ESA confessed we do not know what this comet is, their authority would falter. Silence and soft narratives preserve power. There is also the profit motive. Media thrives on advertising revenue. Panic is disruptive, but controlled awe sells. A beautiful green comet lighting the sky drives clicks and engagement without destabilizing markets. A mystery object defying physics invites dangerous speculation. By choosing the safer story, outlets protect their business. Truth is secondary to stability, but deception, however justified, carries costs. When people discover the gap between reality and narrative, they do not forgive. Trust erodes slowly, then collapses all at once. The institutions that hide anomalies to preserve order may find themselves facing disorder greater than the one they feared. The very act of suppression becomes the scandal. Already cracks show. Independent journalists dig into amateur data, publishing exposés about withheld images. Whistleblowers leak hints of internal debate. Social media amplifies every discrepancy. A press release that calls the comet ordinary sits beside a forum image, showing an anti-tail brighter than the main tail. The contrast is damning. In this way, deception becomes unsustainable. The comet will emerge from behind the sun. Amateurs will photograph it again. If anomalies persist, the media narrative will break. Governments will scramble. And the public, long suspicious, may feel vindicated, even betrayed. The tragedy is that transparency might have prevented this. If institutions had admitted uncertainty from the start, if they had said, "We do not understand why this comet behaves this way, but here is what we know," trust might have endured. The public can handle mystery. What it cannot handle is the sense of being managed, deceived, patronized. And so 3 Atlas is not only a comet, it is a mirror reflecting the fragility of trust between institutions and society. In its green glow, we see not only physics defied, but politics exposed. We see how governments fear chaos, how media fears irrelevance, how both conspire to control narratives they no longer truly control. The deception may be well-intentioned. It may be strategic. It may even be understandable. But to the public, intent matters little. Silence looks like concealment. Softened headlines look like lies. And once trust breaks, it cannot be easily restored. Thus, the comet forces us to confront not only the cosmos, but ourselves. Are we a species ready to face mystery with honesty? Or are we still ruled by institutions that believe ignorance is safer than truth? The answer will shape not only how we see 3i Atlas, but how we face every anomaly that follows. For in the end, deception is a temporary dam. The flood of images will come. The truth, whatever it is, will emerge. And when it does, we will remember not only what 3i Atlas revealed in the sky, but what it revealed on Earth, that the greatest anomaly may not be in the stars, but in the silence of those sworn to show them to us. In every age, humanity has relied on its scholars to be the interpreters of mystery. When the heavens shifted, when comets blazed, when stars exploded, it was the scientists, the philosophers, the priests of knowledge who explained what it meant. Their words anchored societies in certainty. Yet in the case of 3 Atlas, those voices have grown quiet. And it is in that quiet, more than in the green glow, more than in the anti-tail, more than in the missing images, that the deepest unease now resides. This is the paradox. The louder the comet speaks, the quieter its interpreters become. Amateurs chatter endlessly, forums overflow, speculation surges. But the official experts, those whose voices should be loudest, recede into whispers. Some issue bland reassurances. Others retreat into silence altogether. It is a silence heavy with implication, a silence that feels deliberate. The world looks upward, sees an anomaly, and hears nothing but the great silence of those meant to explain it. For those who have followed astronomy for decades, this silence is unprecedented. When Halley's Comet returned in 1986, the world was saturated with commentary. When Comet Shoemaker-Levy 9 struck Jupiter in 1994, press conferences dissected every image. When the Hale-Bopp comet blazed across the 1990 sky, scientists filled airwaves with explanations. Even when anomalies appeared sudden outbursts, unexpected fragments, astronomers spoke freely, offering theories, admitting uncertainty. But with 3 Atlas, the pattern has shifted. Instead of abundance, there is absence. Instead of clarity, a fog of withheld words. What explains this silence? Some argue it is confusion. The data are too strange, too contradictory. Scientists fear that to speak prematurely would expose ignorance. They prefer to wait for certainty before issuing statements. Yet certainty may never come. The cosmos does not wait for our comfort. If silence is caution, it risks becoming paralysis. Others argue it is pressure. Scientists do not operate in isolation. They are bound to institutions, to agencies, to governments that fund their work. If those institutions decide that anomalies are sensitive, then the scientists' voices are muted. A telescope operator may see the anti-tail blazing across the screen, but if policy dictates restraint, their findings remain unpublished. Silence becomes systemic. There is also fear of ridicule, fear of being branded sensational. Oumuamua in 2017 scarred many careers. When Harvard's Avi Loeb suggested it might be artificial, he was mocked, dismissed, branded reckless. Scientists remember. They know that stepping beyond the bounds of cautious speculation can cost credibility, funding, even tenure. Safer then to say nothing. Better to let silence shield than to risk speaking the unspeakable. And yet silence itself speaks. It tells the public that something is wrong. In the absence of words, people supply their own. Whisper networks emerge. Anonymous recordings circulate. This is not a comet, one trembling voice insists in a leaked clip. This is something else. Whether true or false, the leak spreads, filling the vacuum left by official muteness. The great silence is porous, and into its cracks rush rumors. The psychological toll is immense. Silence, once a marker of humility, now feels like betrayal. People no longer interpret it as prudence, but as concealment. Each day without explanation fuels suspicion. Each unanswered question becomes proof of conspiracy. Trust erodes, not because of what is said, but because of what is not. This is not the first time silence has been weaponized. During the Cold War, both superpowers cloaked astronomical data in secrecy, fearing that missile detection systems might reveal too much. Solar flares, comets, even asteroid flybys were sometimes classified. The public learned of them only later, if at all. The lesson is clear: silence is never neutral. It is strategy, wielded by those who fear the consequences of speech. But the silence of 3 Atlas feels different. It is not the silence of classification, nor the silence of ignorance alone. It is heavier, more deliberate. It carries the sense of scholars muzzled, of experts afraid to speak truths that institutions forbid. It feels less like the silence of science and more like the silence of suppression. And so the great silence becomes part of the mystery itself. No longer is the question only, what is 3I Atlas? But also, why won't they tell us? The comet and the silence entwine, each amplifying the other. One glows green in the night sky, defying physics. The other glows darker still, defying explanation. Together, they form a narrative more unsettling than either alone. Some see in this silence a confirmation of the scout theory. If 3I Atlas is artificial, then of course governments and agencies would conceal it. To admit otherwise would shatter paradigms, destabilize societies, undermine authority. Better to smother the truth beneath silence. Others interpret it as incompetence, not conspiracy. Bureaucracies overwhelmed, institutions too slow, scientists too cautious. But to the public, motive matters little. Silence, whether from fear, caution, or control, looks the same. The silence also resonates on a deeper, almost spiritual level. Humanity has always sought voices in the cosmos. When we point telescopes skyward, we are not just gathering data, we are asking questions. Are we alone? Does intelligence exist beyond Earth? For decades, the silence of the stars has been deafening. SETI listened, heard nothing, and concluded that the universe is mute. Now confronted with anomalies that whisper of something more, our own institutions fall silent in turn. The silence above is mirrored by silence below. It is as if the universe and our scholars have conspired in muteness, leaving humanity caught between two voids. What does one do in the face of such silence? Some rage against it, demanding transparency. Others retreat into imagination, filling the void with stories of probes and scouts, of messages disguised as comets. Still others turn away, weary of mysteries that offer no answers. But none escape its weight. The silence presses on us all, forcing reflection not only on Three Atlas, but on our relationship to truth itself. Perhaps the great silence is temporary. Perhaps when the comet emerges from behind the sun, institutions will speak again, releasing images, publishing data, explaining anomalies with new theories. Perhaps the silence will end in clarity, but perhaps it will not. Perhaps the silence will persist, even as the comet blazes brighter. If so, then silence itself becomes the enduring legacy of Three Atlas, not the anomalies, not the glow, but the refusal of those in power to explain them. And that is the greatest danger of all. For civilizations are not held together by certainty, but by trust. If institutions choose silence over truth, they corrode that trust. And once lost, trust is harder to restore than any comet is to track. Three-Eye Atlas may pass from the sky, but the silence around it will remain, etched into memory as surely as the comet's tail etched the night. The comet teaches us many things. It teaches us that the cosmos is stranger than we imagine. It teaches us that anomalies are not nuisances, but revelations. And it teaches us, most painfully, that silence is not absence, but presence of fear, of control, of unwillingness to face the unknown. In the end, the great silence is not empty. It is full of implication, full of doubt, full of the truths we suspect but are not told. It is the silence of scholars staring at anomalies and lowering their voices. The silence of institutions calculating what humanity can bear. The silence of a world that sees a comet blazing in the sky and hears, from those sworn to explain it, nothing at all. And perhaps that silence is the loudest message of all. Whenever a strange object enters the solar system, one question rises above all others: could it hit us? The human mind leaps instinctively to catastrophe. We remember Tunguska, the 1908 blast that leveled a forest. We remember Chicxulub, the asteroid that ended the reign of the dinosaurs. We imagine fire raining from the sky, oceans boiling, civilizations ending in a single impact. And when a visitor like Three Atlas defies physics, glowing with unnatural green light and stretching a tail that bends against the sun itself, the fear multiplies. What if this isn't just strange? What if it's dangerous? Astronomers reassure us quickly. The orbit of Three Atlas has been charted with precision. It will not strike Earth, nor even come particularly close. Its path takes it past Mars, then arcs outward again, destined to fade into the dark between stars. On every orbital model, Earth is safe. The world is not ending. Yet still, in whispers and late-night forums, the question lingers: what if? Let us imagine for a moment the worst-case scenario. Suppose the orbital data were wrong. Suppose gravitational nudges altered its path. Suppose this comet or this probe or this unknown something veered toward us. What would happen? The answer depends on its size and composition. If Atlas is roughly 5 to 6 kilometers in diameter, as estimates suggest, an impact with Earth would be devastating. Larger than Tunguska, smaller than Chicxulub, yet still capable of triggering a global catastrophe. Oceans would roar into tsunamis. Dust and debris would blot out the sun. Crops would fail. Civilizations would falter. We would, for the first time, face extinction not in theory but in reality. This is the nightmare scenario, the kind of vision that fuels apocalyptic films and survivalist fantasies. It is easy to imagine because it has precedent in Earth's history. And so it seeps into our imagination now, attaching itself to Three Atlas like a shadow. But here is the truth: this nightmare will not come to pass. The orbital models are not wrong. Thousands of observations from telescopes around the globe confirm its trajectory. Even with perturbations from planets and solar winds, the object will miss Earth by millions of kilometers. The physics of orbital mechanics is cold, certain, unyielding. On this point at least, the silence breaks into clarity: Three Atlas will not hit us. Why then indulge in worst-case visions? Because they reveal something deeper. The fear of impact is not really about physics, it is about psychology. It is about our awareness that the universe is vast and we are fragile. Every anomalous comet reminds us of our vulnerability, of the thinness of the atmosphere that shields us, of the precariousness of our survival. 3I Atlas frightens us not because it threatens to strike, but because it reminds us that others could. This is why officials often address impact fears first. It is the simplest reassurance to offer. No risk of collision, they say, and in saying so, they hope to calm the public. But the real mystery of 3 Atlas lies elsewhere. The danger is not physical but existential. The shock is not that it might kill us, but that it might prove we are not alone. Think of it this way: an asteroid impact would end life as we know it, but the discovery of alien intelligence would end our worldview as we know it. One is biological death. The other is cultural, spiritual, philosophical transformation. Which is worse? Which is harder to survive? For some, the second is the greater threat. If 3 Atlas is artificial, if it is a probe or a fragment of an alien machine, then every story we tell about ourselves changes. No longer are we the center of intelligence. No longer are we alone. Religions would be challenged. Philosophies would be shaken. Governments would scramble to control the narrative. Our place in the cosmos would collapse, not from an impact, but from a revelation. This is why the worst-case scenario is not a collision, but a confirmation. Not fire and ash, but knowledge. A kind of apocalypse of meaning. And unlike orbital models, no trajectory can rule that out. Here lies the tension: the public craves certainty, but certainty is impossible. We can say the comet will not hit us. We cannot say what it is. And so, in the vacuum left by certainty, worst-case visions multiply. Some imagine extinction. Others imagine revelation. Both unsettle. Both keep us awake at night. But the narration of this story must be honest. Let us be clear: 3 Atlas is not a danger to Earth's survival. There will be no impact, no tsunamis, no nuclear winter. We are safe, at least in the physical sense. This is not the doom of dinosaurs. That fear, however primal, is unfounded. Yet in removing that fear, we are left with another, subtler one. What if safety is not the point? What if the comet is not here to kill us, but to teach us? What if the universe is whispering through its green glow, asking us to reconsider our place in the story of existence? That is a different kind of worst-case scenario, one where survival is assured, but innocence is lost. And so we end with a paradox. The worst-case scenario is not an impact, but a shift. Not destruction, but revelation. Not the end of life, but the end of our illusion that we are the only life. To some, that is exhilarating. To others, it is terrifying. But it is the scenario we cannot dismiss. The rebuttal is clear: Earth is safe. The orbit is stable. The skies will not fall. But the deeper truth lingers: safety of the body does not mean safety of the mind. We may escape fire and stone, but we may not escape the shattering of our worldview. And in that sense, the comet remains dangerous not as a weapon of extinction, but as a herald of change. So the next time someone asks, will it hit us? Perhaps the better answer is this: no, it will not. But it may strike something deeper than flesh and bone. It may strike the way we see ourselves. And that impact, though invisible, could be the greatest collision of all. Every mystery has a moment of pause, a breath before revelation. For 3I Atlas, that pause is the sun. As it arcs behind the solar glare, hidden from our instruments, the world waits. The telescopes fall silent. The cameras record nothing but blinding light. It is as though the comet has slipped into another realm, shielded by fire, invisible to those who seek it. But soon, perhaps in weeks, perhaps in days, it will emerge again. And when it does, the world will look differently. Not only at the sky, but at itself. This anticipation is not new. For centuries, comets have vanished behind the sun only to return brighter, stranger, more spectacular. Sometimes they fragment. Sometimes they flare. Sometimes they fade, humbled by heat. With 3 Atlas, the anticipation carries a sharper edge. Because what we wait to see is not only whether it survives, but whether its mysteries deepen or resolve. The three great anomalies remain like unanswered riddles: the unexpected brightness, the abnormal expansion, the green glow with its impossible anti-tail. Each is peculiar alone. Together, they demand explanation. Scientists admit as much in private. Publicly, they say little. But among amateurs, the expectation is fevered. Will the brightness continue to spike? Will the coma expand beyond any model? Will the anti-tail sharpen into a line that looks less like a comet's feature and more like propulsion? The answers, whatever they are, will change the story. If the anomalies vanish, if brightness stabilizes, if expansion slows, if the tail returns to normal, then perhaps the comet was never extraordinary. A strange visitor, yes, but natural. We will file it alongside Oumuamua and Borisov curiosities, not revelations. The story will fade, and trust, however bruised, may heal. But if the anomalies persist or worsen, then the questions intensify. If the brightness grows beyond reason, if the anti-tail stretches defiantly against physics, if the green glow sharpens into something patterned, then silence will no longer suffice. Even the most cautious institution will be forced to speak. The world will demand answers, and silence itself will collapse under the weight of the evidence. This is why the return of 3 Atlas matters so deeply. It is not just the return of a comet. It is the return of accountability. It is the moment when institutions must either explain or admit they cannot. It is the moment when silence, the great shield of power, will shatter beneath the eyes of billions staring at the same sky. Yet the question is larger than data. It is about meaning. When the comet reappears, humanity must decide not only what it is, but what it means. Is it natural? Then we are reminded that the cosmos is stranger than our models allow. Is it artificial? Then we face the revelation that we are not alone. Is it something in between, neither wholly natural nor entirely engineered? Then we must confront categories we have never known. In this sense, the return of 3 Atlas is less about astronomy than about philosophy. It is about whether humanity can face the unknown without flinching, whether we can admit uncertainty without collapsing into fear, whether we can embrace a cosmos that may be alive with intelligence without tearing apart the fragile fabric of our societies. And here lies the closing paradox. The comet may reveal everything or nothing. It may resolve the mystery or deepen it. But either way, it will leave us changed. Because once we have waited with such expectation, once we have stared at the sun itself in hope of what lies beyond, we cannot return to indifference. We are marked by the waiting. We are shaped by the silence. We are transformed by the possibility. Perhaps the comet will pass and the story will fade. Perhaps in 10 years, 3 Atlas will be a footnote in astronomical catalogs cited in papers. Few read, remembered only by those who followed its green glow across the sky. But even then, it will remain in memory as the moment we wondered. The moment we looked upward, not for beauty, but for truth. Or perhaps the comet will not fade. Perhaps it will ignite a new chapter in the human story. Perhaps its anomalies will prove undeniable, its patterns unmistakable, its silence uncontainable. And then the world will know what philosophers have suspected, what poets have whispered, what dreamers have long believed, that we are not alone. Until then, we wait. We wait for the comet to emerge from behind the sun. We wait for the silence to break. We wait for the truth, whatever it may be, to finally show itself. And in that waiting, we are united not by fear, not by certainty, but by wonder. For this is the final lesson of 3 Atlas. It is not the threat of collision, nor the promise of revelation. It is the reminder that mystery itself binds us. That to live is to not know, to hope, to question, to watch the sky and feel both small and infinite at once. So when the comet reappears, remember this: the mystery is not only in the object, it is in us. It is in how we look, how we listen, how we respond to silence with imagination. The comet is a mirror, and in its green light, we see not only the universe, but ourselves, fragile, curious, restless, forever reaching for meaning in the vastness of space. And as the comet emerges once more, glowing against the darkness, one truth will remain, whatever it is. Its mystery belongs not to governments, nor to agencies, nor even to scientists alone. It belongs to all of us, to every eye that looks upward, to every heart that beats with wonder, to every voice that whispers, in awe and in fear, that the universe is greater than we imagine. When it appears again, we will tell our children we looked up together, and that perhaps will be the greatest revelation of all.